All right, welcome to CS50. This is the start of week 8. As you see on the big board here, we have our own little big board, which is currently ranking those who have tackled PSET 6 already. Realize this is purely optional. It's really just meant to add a fun twist to what's otherwise an interesting assignment. And you'll notice that I was number 1 on this board for like the first 5 minutes of having put it up. And then I was quickly crushed by several of the teaching fellows, most of them former students themselves. And we already have an appearance of several students, and over the course of the week, we'll see others. Realize that right now, the lower bound, if you're a little nervous or socially awkward about even having your name and your results put up there. So right now, the lowest number is perhaps intentionally infinity amount of memory and amount of CPU cycles. So there's a nice, healthy lower bound already. And then the upper bound right now is by our own Drew Robb, who I think was atop the big board last year as well. So he is perhaps among those of you more comfortable this year, the guy to beat. But again, this is purely for fun. So the past many weeks, we focused on this fairly low-level language, C. And hopefully you've gotten a sense, for better or for worse, how you can really manipulate a machine on down to the specific bytes in memory. Now, that's often for the worse, since you've induced plenty of seg faults by now. But finally, this week, do we take things to a so-called higher-level language? This language is called PHP, and next week, a little bit of JavaScript. And these are higher level in the sense that they hide a lot of those low-level details that on the one hand are empowering, on the other hand are also very dangerous and very time-consuming. Problem set 6 has you implementing the fastest dictionary that you can. And part of that involves implementing a hash table or a trie, these fairly intricate and very powerful data structures that thankfully you get for free in a lot of languages. That is to say, in PHP, if you need a hash table, you pretty much write $ hash table, done. You can start using it. You don't need to reinvent that wheel yourself. And this is true of many languages: Java, PHP, Perl, JavaScript, and a whole bunch of others. So the point of this week and next is to now take a big step upward in terms of your familiarity with languages and problem solving, so that you now have more tools to choose from. So as much as we've emphasized C in this course, it is absolutely the wrong language to use for a lot of problems. For instance, all of these little demos I've done with the Twitter site and the event site and the news site, absolutely should you not use C to implement those kinds of websites, because it will just take you way too long. And you'll have to implement so many annoying low-level details. It will, one, completely take the fun out of the entire experience, and that itself is valuable to actually enjoy what you do. And two, you're just going to literally be reinventing wheels that other people have packaged up nicely in newer, more modern languages. So you'll find that this week onward and after CS50, hopefully you'll have a sense now of how these machines work and how you can really manipulate them, especially this week with PSET 6, to your will and to maximize performance. But it's not going to be the only tool in your toolkit. And among them, henceforth, will be PHP, JavaScript, an actual database, and some more. So to do this, to start writing web-based programs, which frankly really allows us to do, well, let me take a step back. What's the point of doing web-based programs? Well, almost everyone these days has a browser. And the alternative would be to have someone download a .exe file or download one of those Mac DMG files and actually install it. So writing software that real people download and use on their computers actually is kind of annoying. There's a lot of steps involved. And the worst thing is, perhaps, that you have to write the program for a specific operating system or even for a specific CPU. So if you want to write a program in C that both your Mac friends can use and your Windows friends can use, you kind of have to write it twice, or at least compile it twice, so that it works on two very different operating systems. GCC, we've been using, uses libraries and whatnot that have been designed for Linux. You can use GCC on a Windows machine. You can use it on a Mac. But you're going to get somewhat different output because of the various libraries that differ on those operating systems. So these days, the web is increasingly the GUI, the graphical user interface of choice. And Google, for instance, has really capitalized on this. Most of you, especially for student groups, probably use like Google Calendar or Google Docs, Google Spreadsheets, all of these things. So Google is kind of banking on this world of Microsoft Office and these client-side programs being a thing of yesteryear. And the web is now going to become one's primary user interface. All the better, because it means you can write software that anyone can use irrespective of their Mac, their PC, their actual operating system. So with that said, what does it take to write web-based software? So in what language are all web pages written? So this thing called HTML. Now, HTML looks a little cryptic at first glance. I'm on the course's home page here. I'm going to go ahead and go up to page source, and you're going to see a whole bunch of stuff that probably or hopefully looks like Greek to many of you at this point, but there's clearly some patterns. There's a lot of TDs right there to render that table of contestants on the home page. But this stuff is just called HTML. And as the indentation suggests and the various color coding, there is fortunately a structure. HTML stands for Hypertext Markup Language. It's not a programming language because you can't implement logic with it. You can just mark up information. So starting today, we'll start making some web pages using HTML. And HTML essentially tells the computer how to render actual data. Here is a word, foo. How do you want to render this? I want to render this as bold. So you use various tags, things between open brackets and close brackets to say, make this bold. And then you will explicitly tell the browser, stop making this bold. So how does one go about learning this? Well, literally after my Math 20 class years ago, I had a really nice CA. He was like a senior at the time, Kirkland House, and I asked him for some reason, how do you make web pages? And he was a really nice guy. And we went down to the lab in the basement of the Science Center, literally after section one day, and he spent like 40 minutes teaching me how to make web pages. And that's all it took. Now, the thing was a god-awful mess, the first thing I made. It was hideous. I downloaded every ugly, annoying graphic that you could find on the web. Things were flashing and spinning and blinking, but it was mine. And it was really cool to then email this URL out to my unwelcoming family and friends to say, look at me, my presence on the web. So that's going to be you in just a few days' time. I had perhaps a little too much fun or a little too much awkwardness this morning when trolling through some archives. There's this wonderful website called the Wayback Machine. Oops, well, I won't use that one, called the Wayback Machine. And it led me to a bunch of links that this computer program maintained by some nice volunteers had led me to archives of old websites that I actually made. Now, this actually is not the very first. Unfortunately, that has been lost to time. But this was apparently my original homepage. So apparently I had a thing for my initials back then, even then. But this is one of the worst design decisions you can ever make. Before you can view my website, tell me who you are. Like, you had to actually type something into this, your name, please, and then hit enter. Unfortunately, the archiving program on the web that does this didn't know how to actually submit its name, so you get this. So unfortunately, that content has been lost. But then I realized if I fast forwarded a couple years in these internet archives, I then found this. This is more embarrassing than anything, but I thought if I embrace it and say, yes, this was me, you won't find it yourself by Googling and then make fun of me. So I had this computer in my dorm room called FROGMAN because I had this. This is just a confession. So FROGMAN. So this was Kermit the Frog dressed as Batman. For some reason, I thought this was cool at that age. I scanned it in. I said, I need a host name for my computer, which they let you choose at the time. So I called it frogman.student.harvard.edu. And you can actually click through here. Turns out, what did I have here? About Frogman. I mean, it's really... Frogman was born on an unknown day in January of 1998. He is a 486-33 PC running Red Hat Linux. I was really kind of a geek. I was apparently a senior at the time. What did I have? This was actually kind of embarrassing. As I told you, I think week 0, I ran for UC president and lost. You can see my whole campaign. Oh, you can't? Oh, my campaign platform has been lost. Oh, well. Just as well. Anyhow, I shouldn't get caught off on a tangent, but the point is, let me at least make this academically motivated. If you look at this stuff, it's the same stuff. So 12, 15 years ago, the overall structure of these pages really hasn't changed. And that's the funny thing. So the web was invented kind of by accident, at least give its current popularity these days. But every web page out there boils down to structure like this. And this is a bit misleading because some of the standards have changed. So you see a lot of capitalization here. And this was code I wrote 15 years ago. But the overall basics are the same. So what we'll focus today on is making some very simple web pages, then very quickly moving to a more sophisticated environment, PHP, which will allow us to generate web pages dynamically. So let's see, even for those of you a bit familiar with this stuff, if we can't fill in a few blanks. So when you pull up a web browser and go to www.cs50.net and hit enter, what happens? Well, your computer, whether it's a Mac or PC, sends out a request to a local server called a DNS server, domain name system server, and it says, hey, what is the IP address of the website called www.cs50.net? The reason for this question is that every computer on the internet, small white lie, has a unique address called an IP, Internet Protocol address, and this is a number of the form something dot something dot something dot something. So it's 4 numbers separated by periods, each one of which can be between 0 and 255. So IP addresses, if you're following along quickly, are how many bits total? Little quiz. So it's 32 bits because you have 4 numbers, x.y.z.w. Each is between 0 and 255. That means you're using a byte, 8 bits, so you've got 32 bits. So anyhow, every computer on the internet has an IP address. So this thing called the DNS server hands back to your computer the IP address of cs50.net, which is 1.2.3.4 or something like that. Your computer then makes a request out on the internet for the computer with address 1.2.3.4. There's all these machines on the internet called routers or gateways. These are just fancy computers whose pretty much sole purpose in life is to take data in from one direction and then send it on its way in another direction. And maybe that data coming in from here belongs that way, or maybe that way, or maybe that way. So if you think of a router as being just a computer in the middle of the United States, clearly there's many different directions in which data can flow. And the purpose of these devices called routers is to get data from point A to point B. Typically, there will be 30 or fewer hops between point A and point B. That is a max of maybe 30 routers, and typically it's like 10 routers between points A and points B. OK, so an IP address, just like a US postal address, uniquely identifies a house or a mailbox. An IP address uniquely identifies computers, and thanks to these routers, which are very intelligent, they pretty much know based on that number what direction in the country or in the world that actual machine lives. So finally, this request makes it from my little laptop to cs50.net. There is a thing called a web server running on that computer. It then realizes, oh, this is a user. They have requested www.cs50.net. Let me return to them the CS50's homepage. Well, what is it that the web server actually returns? Well, the web server returns pretty much just a text file. And let me switch back over to this computer here. It returns a text file that comprises all of these things called tags, otherwise known as HTML. So now my Mac or my PC is in receipt of a big text file like this. Inside of this file are some pretty basic instructions, one of which down here says open bracket body. And that's essentially telling the browser, hey, browser, here comes the body of the web page. And then below that, it says open bracket table. Well, that's telling the browser, hey, browser, here comes a table. And based on these instructions, these elements or these tags, the browser renders the information accordingly. In fact, if I scroll down a little further, let me scroll down to where we actually see some familiar names, perhaps. And right here, even though we have a big old mess going on, all of this was computer generated. So it's not like I or the TFs had to type this in manually. Notice that we see Drew Rob's name there at top right. And Drew Rob's name is inside of a tag called, there we go again, TD. OK, so this is just a teaser. So we'll look at the specifics of this in just a moment. But my computer has just received this really big text file. So what is a browser's purpose in life after requesting a web page and getting back a big text file? It parses this file. It reads this file from top to bottom, left to right, and it does precisely as this file tells it to. If it encounters certain special tags that says put an image here, put a sound here, the browser recursively requests those files as well. So most web pages these days have graphics. We've got the logo up top. We've got the photograph at top right there, SES's logo. There's a lot of files included inside of this one web page. So what a browser does, again, is it recursively goes through and requests any files that are mentioned inside of this HTML page. As an aside, now that you're sort of mature enough, computer science-wise, to understand, if you go to google.com, if you've ever searched for recursion and hit enter, have you ever noticed this subtle joke? So some geeks still over at Google. Anyhow, if you're not sure why your classmates are laughing, maybe ask the person next to you. But Hopefully you're OK there. OK, so that's the story, right? So we've got this internet, which gets data from point A to B. Computers like mine can send requests across this internet and say, give me your home page. What comes back is just a big text file. That's called XHTML. And the browser, upon receipt of that, reads it top to bottom, left to right, and does what the file tells it to do. Well, let's see if we can't fill a file like this ourselves. So this is just a Windows PC here. I'm going to go ahead and run a trivial little program called Notepad. Right, this is all it takes to start making web pages. I'm going to change my font just to be bigger so you can see what I'm typing a little more effectively. But what I'm next going to do is this. And I'm going to cut some corners, and we'll clean things up in a moment. But I just want to make a web page. So I'm going to tell the browser, all right, browser, here comes a web page written in a language called HTML. And I'm going to preemptively close this tag. So in HTML, anytime you open a tag, you must close it. And now let me be more precise. HTML is the language most web pages are written in. It's a complete mess. It has gotten messy over time. Browsers have gotten very forgiving over time. So we'll actually use in the course a language very similar in spirit called XHTML, Extensible Hypertext Markup Language, which even though you will notice inconsistencies like this, I didn't write XHTML, but I'm about to start using XHTML. Essentially, XHTML is the clean version of HTML. And by that, I mean when you open a tag, you must close it. And we'll see some other subtleties in a moment. So those tags colloquially will say, browser, here comes a web page written in this language. The close tag says, that's it. I'm done. So up here, you can actually have one part of a web page called a head. And I'm going to open that tag and close it. And then the other part of a web page is called the body. And I'm going to close that. So web pages have two parts to them, head and body. Essentially, the head is anything in the title bar and stuff like that. The body is 99% of the web page. So actually, the stuff inside the browser window. But one of the only things we can do in the head for now is to put a title. So if I want to name my web page Hello World, and then close title. And then if I want to put something really simple in the body, I might say literally, Hello World. All right, I'm going to go up to File, Save. And I'm going to save this onto my desktop. And I'm going to call this hello.html, which is the convention for most web pages. Now if I go back to my desktop, I have this file called hello.html. And per the icon that Windows has automatically assigned to it, this is actually a web page. So that is my very first web page. Kind of a misnomer, because where is this file not? On the web, right? It's on my desktop. So if I, kind of like an idiot, go and copy paste this URL up here and tell all my family and friends that, oh, I just took CS50, learned how to make web pages, visit here, like they're going to get an error because they're going to click that link and they're going to try to open their own copy of hello.html in their own mail-in folder, which really doesn't make sense on their local computer. So clearly we're missing a step. We now need to move this file out onto the World Wide Web. All right, well, thankfully, we have access to web servers. In fact, in the course, we have our own server called CS50.net. We now have this new infrastructure that we mentioned last week and you're going to use for PSET 6, which is cloud.cs50.net. And just as cloud.cs50.net lets you use SSH and compilers, it's also running software called a web server, which is software. It doesn't necessarily refer to a physical device, which means you can go to cloud.cs50.net with a browser and actually see its home page. Now, unfortunately, there's really nothing there on cloud.cs50.net. If I go ahead and hit enter there, I get this error because we're not using it for actual presence. But in fact, if I go to this URL, which I'll tease apart in a moment, ~cs50, pset 6, and then go to bigboard.cgi, what you'll actually see is that that table that you're seeing on our course's homepage actually lives on the cloud, because after all, that's where you're going to be running your own problem sets code. So I've just generated on the cloud this file here that using some PHP tricks I then integrate into our course's website. But the takeaway for now is that cloud.cs50.net is a server. So how do I actually get my content there? Well, let me go ahead and do this. I'm going to go ahead and SSH to cloud.cs50.net. I'm going to go ahead and double click my settings because I've prefabbed it here with PuTTY. I'm going to log in as CS50. You would log in as yourselves. And now I have this little prompt here. It's identical in spirit to nice.fas, except now we have more control over things. And if you want to start hosting a website on a typical server, what you would first have to do is write mkdir public HTML. The world has adopted some conventions that says all web pages for a user must live in a folder called public HTML. All right, so I go ahead and do that. I can now go into my public HTML directory. Now I need to actually put some content there. So actually, I'm going to go ahead and do nano and then hello.html. And you know what? Let me go to Notepad. Let me copy this. Let me paste this in here. I know that's very annoying when that happens too. Let me go ahead and fix this the fancy way. There are ways to avoid that, but this will be faster. OK, so now I have a file called hello.html that's inside of my cloud account, identical in spirit to your having .c files and .h files in your nice accounts and now your cloud accounts as well. So let me see what happens. If I go to now cloud.cs50.net, so cloud.cs50.net. And then because I'm a user on the server, you have kind of an ugly URL. So for problem sets 7 and 8, you guys too will have kind of ugly URLs. But this is the convention when you're on a shared server with hundreds or thousands of other people. I'm going to type tilde CS50 and then enter. And what this is showing me now are the contents, not of my home directory, because that would be kind of bad if people on the whole internet now could see inside of my home directory. But you do see that this is apparently the contents of what folder? Whose folder's contents are we now seeing? And I kind of tricked you. I had a public HTML folder already, and there was already some stuff in it. But this is my public HTML directory. So notice this is just one of those things you've got to remember. So even though when you're on the command line using PuTTY, using SSH, something like tilde CS50 actually denotes what directory? Your home directory. There's this dichotomy. Once you're using a website, tilde CS50 or tilde foo, tilde Malin actually refers to Malin's public HTML directory. So when you're using the web, the tilde means something a little different. All right, well, that's fine. Let me go ahead and now click hello.html. And I seem to have a problem. So it's forbidden. And this kind of defeats the whole point of the web. So what probably is the solution here? Or just intuitively even? So it's forbidden. You do not have permission to access this file on this server. So we need to give ourselves permission. So I'm going to go over, and this is not something most of you have had to do for problem sets yet, but I'm going to go ahead and let me do ls-l hello.html. Anytime you do @-l, remember that's the long listing, and it gives you some more information. And we've started to discuss this in the current problem set and even in past ones. So now notice I apparently have a file called hello.html. This is when it was made, 1:33 p.m. It's owned by user CS50. And then there's these things over here. So these little hyphens actually are a bad thing because what those hyphens indicate are the permissions for a file for myself, the so-called owner, followed by my group, which happens to be CS50. But you guys on the cloud are in a special group called students, and we generally are in staff. So we have myself, which are the first 3 bits, 3 hyphens here. Then there's group permissions. And then there is the whole world permissions. Now, the fact that mine say RW is a good thing, because that means I have the ability to do what 2 things? Read and write the file. That's all that means. So apparently, all I need to now do is give everyone else that ability. And we'll discuss some of these conventions in problem set 7's PDF. But I'm going to run a command called chmod, change mode. And what I'm going to say is change the mode of this file to 644. Which we'll discuss again in that problem set. But let me just do an ls-l again of this file. Notice that that has had the magical effect of giving everyone else read permissions. I don't want to give the whole world write permissions, but read permissions is good, because now if I go back to my browser window here and click reload, voila. I see my very simple web page, helloworld.html. All right, so now let's try to do some things that are a little more interesting. And I'm actually going to go into some prepared examples, which you have printouts of today. And I'm just going to look at this version of hello.html. So at the top of this file, ignore the messiness just because of my font wrapping. Let me go ahead and delete a few of these just so it doesn't confuse. So this is an arbitrary convention. In HTML, just as you can have comments in C, you can have comments in XHTML or HTML, open bracket, exclamation point, hyphen, hyphen. Then you put most anything you want. And then below that, you have hyphen, hyphen, close bracket. So that's a comment. Now, the fact that I used all the stars and the /*, it was me just being anal, trying to be consistent with all of the C examples we ever did in the course. But you can put anything you want pretty much between those comments. But the magic really starts to happen down here. So this is pretty much the same exact file as I typed on the fly using notepad.exe. But notice that there's a few differences here. And you do have a printout of this for notes. These first 3 lines here are simply necessary. When you implement a web page in this language called XHTML, you unfortunately have to type this god-awful sequence of characters that even I have never once remembered. I always copy and paste it from some previous code I've written. But this formality, which was agreed upon by a group of volunteers, it's an organization called the W3C. It's a standards group that essentially has said, if you want to write code in this language called XHTML, your page has to start with that. Now, you can have some comments and stuff, but the page has to start with that. So this, too, for the course, just a copy paste. And now there's one other difference that you have to do, which I was lazy about a moment ago. When you write open bracket HTML, to make sure your code is valid XHTML, you also just need to copy paste this XMLNS thing with the equal sign and the double quotes and the URL inside of it. So I'm going to wave my hand at the reasons behind this because they're really just a distraction. But for now, just take on faith that anytime you make a web page for the course or for XHTML in general, these are kind of some stupidities that you have to get started with by copy paste or remembrance, and then you're ready to go. So now we're ready to go. Here is my web page here. I'm going to go ahead and open this version of it. This is all linked on the course's web page. So lectures, source, and this is hello.html. Pretty much looks the same. I've got hello world in the top left of the body. And now notice if I scroll up to the title, notice in the title, in the head of the web page, is the same thing, because that's what I typed. So just a quick change here. If I really want to be sort of obnoxious, especially if this thing gets indexed in Google and I want this showing up in Google results, if I save that and then reload my web page, now you can see that I had this effect there. So we're now literally changing the internet as we type these commands. All right, so pretty powerful stuff. So now let's do something that's a little more interesting. And I'm just going to do some things on the fly just to convey the relative simplicity of this stuff, but really just to emphasize the basic building blocks. It's not going to be fun if we start teaching you the bold tag, the italics tag, the center. There's so many simple things you can do that just a little cheat sheet to your right or left-hand side is really how you learn this stuff. I mean, even when Tim, my maths TF, sat me down and taught me this stuff, he kind of did some of the basics, helped me understand the framework. And then anytime you need to learn something new, you look at someone else's web page on the internet, or you look in a manual, and we'll link to a number of resources on the website. So let's do something simple. I have decided that besides hello world there, I want to actually, and I'm just going to zoom in here so it's more readable, I'm going to go ahead and make this hello bold. So it turns out there is a tag for bold, open bracket B, close bracket. And if I save my file, then go back here and reload, notice that hello has indeed become a little more bold. All right, so that's great, but kind of a useless web page. Let me go ahead and put some other stuff there. Welcome to my first website, exclamation point. I hope you enjoy your stay. It's pretty much what my original web page was. So now I'm going to go back here. I'm going to reload. Not really what I intended. So what's the obvious aesthetic bug? So I'm missing new lines. So it turns out that web pages by design can have white space, but it's completely ignored by the browser other than single spaces. If you hit the space bar once, the browser notices. Hit it twice or hit the enter key, stops noticing. So if I reload now, still no difference. So that's because this is a markup language. If you want a line break, you must say break here. So BR is the line break instruction. If I want it there and there, I'm going to simply put it twice. And now a word on the syntax in just a moment. But let me reload. And now, OK, still hideous, but at least I'm starting to make sense of the general syntax here. So why did I do this thing here? Well, it turns out there are some tags that take what are called attributes. You can take a tag and you can tweak its behavior by adding what's called an attribute to that tag. So let's see, what's one that I might want to do? You know, I'd really like to start centering this text. So one approach to doing that is, and there are more modern ways, but I'm going to keep it simple. I'm going to do center. And now just to be anal, much like we advise in C, and in the code you've been writing so far, I'm going to re-indent everything manually, though some tools can facilitate, just to keep everything clean. So anytime I open a tag, stylistically, I indent by 2 spaces, 4 spaces, just be consistent. And now what I have is a web page that's not only line by line by line, but it's also now centered. All right, so that's good. But now this is not really explaining these slashes here. And it's not really a web page. It's kind of a dead end. Right? The whole point of the hypertext markup language is to actually link to other hyperlinks. I've got none of that. So let's actually say a link at the bottom here. My favorite site is www.cs50.net. Let's do that. Reload. OK, that's great. But now you're going to get users, still a dead end. So unlike a lot of popular websites, FML and the like included in Facebook, when you post a link, normally these days, they automatically get hyperlinked. Well, that's because someone at Facebook wrote a few lines of code that examines anything you type into their website, realizes, oh, this starts with www, this ends with .com or .net. I'm going to assume with high probability this is a URL. Let me make it clickable. How do you make something clickable? Well, you have to actually use one of these tags. So I'm going to say open bracket A for anchor. Where do I want this link to lead? Well, the attribute is called hyperref or href. So I'm going to do quote unquote. And now I'm going to type the actual URL that I want the user to go to, close quote, close angled bracket. And now at the side here, Vim, the editor I'm using, and let me actually move this onto a new line for space, it's already highlighting it. That doesn't mean I can click it here. This is just an aesthetic thing. So let me go ahead and say, stop treating my text as a hyperlink. What's the command for that? Yeah, so \A. And now period. And actually, and I can keep saying more stuff to emphasize that this link is inline. I have a whole bunch of text, but the only part that's underlined is the thing between the anchor tag and the close anchor tag. Popular mistake, and you may have seen even websites like this, though not that common in corporate websites, do something stupid like, oops, close B, which is kind of nonsensical. Now weird things happen. And this is where browsers have gotten, quote unquote, forgiving over the years. 10, 15 years ago, when this stuff was starting to catch on, there really weren't people saying, let's adhere to these standards. The thing grew up fairly organically, and browsers started competing among themselves for various features. So you will find over the next several weeks that sometimes your website looks different in IE versus Firefox versus Chrome versus Safari. And frankly, it's just a big old headache. And it's largely because companies have never once agreed properly on certain interpretations. For instance, in this case here, what is the right approach? If you have an open A tag but a close B tag, should I just assume it was a mistake and stop hyperlinking it? Or should I, and this is why, when you get ambiguities, it's unclear what the browser should do. So some browsers do different things. But we're going to fix, and I'm going to realize that if I now click this link, I in fact get whisked away to CS50's homepage. All right. And it laughed again. All right, so what do we have that's interesting here? We've got tags, open and closed. We have attributes like this. This is an attribute that modifies the behavior of a tag. So it turns out that tags, aka elements, can have 0 or more attributes. I say 0 or more because this guy doesn't have an attribute, this guy doesn't have an attribute, this guy doesn't have an attribute, but this one does, because not only are we telling the browser, here is an anchor, here is a clickable link, you have to tell that tag where it goes. And so the general structure for all of these tags is generally this format. Open bracket, tag name, then 0 or more of the following. Attribute equals quote unquote value. Attribute equals quote unquote value, and so forth. Well, now we can use the same idea and actually use some attributes. It turns out, and I know this because I read the manual or I went to class, there is a BG color attribute for body. So I can actually say that I want my web page to be, say, red. Let's actually go back to this page here. Whoops. Let's go back here to hello.html. OK, so now it's actually starting to look like my original home page. So what else can I now do? Well, this is already getting sufficiently hideous. Is there anything else you would like to see how we do before we forge ahead with less ugly things? What's something you often see in a web page? Flashing. OK, so there is a tag from yesteryear called blink, which was actually deprecated forcibly by several companies because they hated web pages that would blink text like this. But we can mimic this. All right, we'll show one thing which is actually useful. Let me go ahead and search for something called an animated GIF. So a GIF is a graphical format. You guys played with BMPs this week and with JPEGs. You've probably seen GIFs. Unfortunately, the world has spent a lot of time making really ugly things that blink and spin and dance. One of them, we have apparently 5,000 here. Let's see if we can find something about computers. This is just some random website from Google. The site is for sale if you're interested. OK, so right, this is the web as I knew it in like 1995. Like this. I mean, this is what it looked like. Little graphics like this, little disks popping out of toasters. I mean, this was the internet. So, I mean, it kind of was. Whoa, OK, and those are pop-ups, which have largely been done away with, too. Let's pick something here. All right, let's pick this guy. So I'm going to click this graphic. And now just to demonstrate a common workflow, especially for final projects and for the next couple of problem sets, I want this guy in my web page. So one way I can do this is I can copy the URL here. I can go back to my little file. I'm going to put a line break because I'm going to put this graphic at the very bottom. And I'm going to use the image tag succinctly, just like C. It's not image, it's img. I need to tell the browser the source of this image. So I'm going to go ahead and give it that URL. And then because there's no need to close a tag like image, right, the image is either there or it's not. You don't start putting an image, do some stuff, then stop putting an image. Just like a line break is similarly this atomic idea. Either do it or don't do it. You can't start and finish a line break. That's why here, too, I put this angled bracket in here. So to be clear, this would be correct code, but it just looks stupid. Like open tag, close tag, it's all kind of wasteful in terms of bytes. So the world has this convention where you can actually put the slash inside of the tag. It's best to do it generally after a space like that. And that just says start and stop immediately because there's nothing going to go inside of this anyway. So now let me save this. Let me go back to the browser. I'm going to go to my web page, not that guy's, reload. And now, wow, my web page is really getting fancy. Now, there's an interesting aside. This is generally frowned upon, linking to someone else's content. Now, even though this image is only like 4 kilobytes, I'm right now hitting reload a lot. Every time I reload my web page, my browser is hitting not only the cloud, but also what? That guy's web server. So this generally is a bad thing if you link to someone else's server, because it means visitors come to your page and he or she pays the bill for all of the bandwidth, all of the graphics and content that have been coming into this web page. And sometimes content like that will be blocked. So let's do one final step so that you know how to do it. Let me go back to this image. Let me actually save it. I'm going to save it to my desktop here. We're going to call this computer.gif. Don't change the file extension, just the name. Now I have it on my desktop. What's the solution or the, oh, I have one new spam message, one direct buy. You know, we're lucky. This could have been a lot worse, these pop-ups. All right, so what's the solution for getting this image into my own account? You use this probably for pset 5? Yeah, so SFTP. Even though for SFTP you were generally downloading files from the server to your own computer, the program works in the same way in the other direction. So I'm going to use SecureFX. You can use CyberDuck or whatever on your own computer. I'm going to very quickly just configure a new session. If you've never done this before, we'll walk you through it in section or post something online. But I'm going to go ahead and hit Enter. After typing cloud, I'm going to be prompted for my username, CS50. I'm going to type my password. Now notice I've got some other directories because I use this account for other things, but I'm going to go into my public HTML directory. There's my hello.html. So I'm just going to move this window to the side, and I'm going to click computer.gif, drag it over here. Voila, that's all it took to copy the file to my own account. Now we're going to pay the bill for the bandwidth, but so be it. So now I'm going to go back here. I'm going to make the page look the same, but to reference a file on my local account, I'm just going to delete, 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 delete. Type computer.gif, save it, and go here and reload. Damn, what went wrong? What's that? Actually, I asked that. You really shouldn't have detected that. I put it in the wrong place. So that's the academic lesson. I put it in my public HTML directory, but you will not often have this problem. I'm actually in my lecture's source directory. So now let's fix. Now let's reload. OK, and voila. And now notice one thing. Fortunately, SecureFX was smart enough to upload this with world-readable permissions because of the way I configured it. If I do an ls-l for computer.gif, notice that it is, in fact, read and read for everyone, which is good. If it were the opposite, just in case you ever see this, which I'll simulate now, if it looks like that, and now I go back to my web page and reload, what will I likely see? some kind of error or just bad stuff happens. It doesn't actually render, and that's because of a permissions problem there. All right, so we have not made anything pretty there, but at least we've talked about open tags and closed tags and attributes and overall markup. Any questions just yet? Any questions? All right, so this is not the type of URL that one would advertise. Let's actually make this a little more real so that especially after you exit this course, you don't feel like anything you ever do on the internet has to be tied to some harvard.edu server or some cs50.net server. Well, yes, we own the domain name cs50.net because we as a course paid like $9.95 a couple of years ago to actually buy this domain name from a registrar. So there's this whole infrastructure on the internet of commerce. And there are these entities called registrars that you go to a website like GoDaddy.com. Silly name, but they're among the biggest so-called registrars. You hand them some money or you hand them a credit card, and then you can buy a domain name from them if it's in fact available. What does this workflow actually look like? Well, if I go to, and I'll switch us over here. Let's go to GoDaddy.com, but there are dozens of other such registrars. You can typically fill out a little search box like the one here, and you can, search for instance, let's do harvard.com and see if that's still available, because I'd love to scoop that up for $9.95. So click go. Presumably it's not actually owned, and in fact they'll often recommend a whole bunch of domain names you probably really don't want, because who newharvardforyou.com. So kind of silly. This just means it's been taken. So one of the hardest parts, frankly, as an aside, to getting a domain name is finding one that's actually available. Come final projects, one of the options you guys will have is not to just host your final projects on our own servers, because if you're implementing a project that you actually think will be useful to friends and to family, people even outside of Harvard, odds are you want to advertise something like mygooddomainname.com and not something like cloud.cs50.net. So among the things you'll be able to do in a few weeks' time is if you do go to a site like this, buy yourself a domain name, you just have to tell that registrar where in the internet your server lives. So we, for instance, have told GoDaddy a couple of years ago what the addresses are of those things called DNS servers. We type them into GoDaddy's website. We have our own servers now in Maxwell Dworkin, so we just told GoDaddy this domain name lives at this particular IP address. So come final projects, you guys too, if you decide, purely optional, to do a web-based project and one for which you want a vanity domain, your own domain name, you're simply going to have to find some place to put it and then tell GoDaddy where it is. Now, so that your work actually outlives the course's semester, we'll actually put you in touch with those folks called HCS, the Harvard Computer Society, and they will actually provide you with an account on Harvard's campus, but that will create the illusion that your domainname.com is out there on the internet even though it lives on their server. So just a little teaser so that you realize come final projects and beyond, you can actually do this stuff yourself without the crutch of a course's own infrastructure. So this is what we did. To recap, XHTML, this is the simplest valid web page that you can make in this language called XHTML. It's completely underwhelming, just says hello world, but it captures the basic spirit. Now, fortunately, in this world of XHTML, there are tools out there that can help you find mistakes in your code. And one of the things PSET 7 and 8 will expect is that your code be valid. What this means is that when you type open bracket, something, close bracket, you're not making stuff up as you go. You're actually using standard syntax that has been approved and actually exists in the language. And this is simply offered now as a way of helping you debug your own code. Well, there's also this other feature, which we'll give just a teaser of here, called CSS. And the web has actually changed quite a bit from when I made those silly little pages with FROGMAN and my all capital letters and all of my tags versus today. So very popular today is this supplementary language called CSS. So you have HTML or XHTML, which is all about markup, teaching someone telling the browser how to lay out the web page. And then there's this complementary language now called CSS, Cascading Style Sheets, which much more like a word processor allows you to fine-tune the aesthetics. If you want your font to be 18 point, you can use CSS for that. If you want a very specific color, a very specific placement of some element on the page, you can use some CSS. And this CSS is not a language we'll spend much time at all on in the course, because frankly, from the course's perspective, we will be so thrilled if you produce even the most hideous of projects if they are perfectly functional and actually well designed. We will not expect works of art, because frankly, without the help of folks like Yuki and others, this this is what CS50.net would look like if I were in charge. So we don't think that this is now becoming a course about aesthetic design. It's only about functional design. So this clip here reveals one thing more that you can put inside of that head element, those open tag for head and close tag. So besides the title, which I still have grayed out here, you can put a style tag. And a style tag allows you to really control, with a more fine-grained control, the aesthetics of a web page. Well, let me demonstrate. Let me go over to, let's say, hello.html. And let me go ahead to the top of the file. And I'm going to indent and say style type equals text/CSS. Whoops, thank you. So I'm going to put this at the head. All I've done is this. That's before. That's after. I started typing style. Now I'm going to close it preemptively. And things like this are just conventions. There are some older browsers or some mobile browsers on phones that aren't very smart when it comes to tags they don't understand. So you'll often see these sort of hacks or workarounds that have evolved over the years. So for instance, this one here essentially tells a browser, here comes a style sheet. Here comes some stuff written in CSS. But in case this confuses you or if you don't understand it, think of this as a comment. So again, these are just kind of workarounds. Not terribly elegant, but this is what the world has developed. But now inside of this, I can go ahead and put some CSS. So CSS lets you control things in essentially three ways. You can define, in this language called CSS, some properties for actual elements. An element is the same thing as a tag, except that an element comprises essentially the open tag and the close tag, but a tag is just the top thing or the bottom thing. Open tag, close tag, start tag, end tag, similar jargon. So this allows me to control the appearance of a tag or an element. The thing below it with the hash mark means I can control the behavior of a specific tag that has what's called an ID attribute. But don't worry so much about that now. And then also we can define what are called classes. So this is just meant so, to introduce it so that you've seen it. These are aesthetics that you can ultimately worry very little about, or at least when you start reading up on this for PSET 7 and its PDF, you'll understand. Let me go ahead and do the following. Let me go ahead and say that everything in the body of this document, so I'm going to say the name of the element, body, thank you. Let me say the name of the element name is body. Let me go ahead and say, let's make this font size 96 point. All right, so this isn't something I could express as easily in the body of the web page. So let me go ahead here and reload. Wow. OK, so it's getting even worse. All right, and at some point, well, let's see. What else can we do? What about the color? Let's really make it hideous. So what about yellow? Yeah. So, and realize too, I'm using some words, and you can't write things like fuchsia or fairly random specific colors, but you can use your hexadecimal code. So if I actually wanted invisible text, a sort of secret web page, what if I do this? Feels kind of fancy, right? Ooh, come to my web page, and how do you know what I've told you? Well, you can just click and drag and see the message, right? So that's how you can control the body. Let me do one other thing. And again, this is a hideous train wreck of a site so far, but that's not so much the point. It's just to look at some of these fundamentals. Let me go ahead and define a class called copyright. All right, so dot and then a keyword like copyright. And for copyright, I don't want this crazy 96 point font. I want the font size to be smaller. I just want it to be 12 point. So now CSS is cascading in the sense that things you define above can be overridden by things below. So what does that mean here? Well, let's actually put a copyright here. So copyright CS50 at the bottom. If I save that as is and reload, actually, we got to fix this red text here. Let's change the text back to, let's try blue this time. All right. Blue, even worse. Scroll down, there is my huge copyright. So I'd really like to shrink just that. So let me go ahead and encapsulate copyright in what's called a span. This just says span the following line. So span, and then what class do I want to assign to this line of code? Well, what did I call it? Yeah, just copyright, all lowercase, close bracket. Now I put my content, my actual data, which is copyright CS50, then I close span over here. And to be clear, even though in your open tags you do specify attributes, you do not specify them again in the close tag. You just close the original word. Now let me go ahead and reload. and aha, now I have indeed overridden the default font size and controlled it a little more specifically. And using the ID attribute, can you target very specific elements as well. So this is actually all it sort of takes to start making web pages, pretty hideous web pages at that. Let's go ahead and take a 5-minute break and then start making Google. All right, we are back. So notice that there, OK, did it again. Damn it. Take 3. All right, notice that there are a whole bunch of office hours, not only on Thursday nights and Friday afternoons, but also Monday, Tuesday, Wednesday, and even on Sundays. So do, especially if you're finding that you would like a little more one-on-one attention or assistance with the problem sets, and the crazy Thursday nights really aren't conducive to thinking through and understanding things at your pace, do take advantage of the blue and the red boxes that are much earlier in the week, including tonight. So just a reminder on that. All right, so now there's this thing called Google. Right? It's pretty popular, works pretty well, but it uses, strikingly, a very simple interface and some very basic user interface mechanisms, right? And actually, these same UI mechanisms are what compose most every website out there that takes user input. You have these things called forms. You have text fields like this one. You have buttons. You have drop-down menus. You've got little radio buttons and checkboxes. But that's actually about it. To implement forms on the web, you just need a few of these tools. So here's just a quick laundry list, and this is pretty extensive, of how you can actually take input from users. We focused thus far on providing output, aesthetic output, but you have these things called text fields. If I zoom in on this thing up here will allow me, open bracket input, name, email, type equals text. This will tell the browser, put a text box here that the user can type stuff into. Call that text box email. If you instead want a bigger text area where you would actually write a long response or multiple sentences or paragraphs, you have things called text areas. If you want a password where when the user types it becomes little circles or bullets and not actually clear text, well, you just say type equals password for that third one. If you want checkboxes, you say type equals checkbox. If you want radio buttons, the little circular things, you say type equals radio. And then finally, if you want one of those drop-down menus for long lists, you call it a select, and you give it a name, and then you have one or more options beneath. So these are the basic building blocks of every website out there. And it's amazing, frankly, that there exist so many permutations of these very simple elements on every website you use there today. This is kind of it, right? We spent, half an hour talking about the structure of a web page and where these files live and what it takes to get files from servers to browsers. But at the end of the day, now that you have this, or now that we'll start to use this, you have the ability to actually start making interactive user software. In CS50's library, we had getInt and getString. How do you get ints and strings from users? Voila, with these basic commands for getting form elements. And it turns out that on the web, because everything you get from users is typed at a keyboard, which essentially is text, you don't even have to worry as much about floating points and strings versus ints, because it all comes into you, the server, as actual text. So let's see if we can't re-implement as fast as we can Google. So here is Google. Every web browser that you probably used has a feature, even if you've not used this feature, called View Source. So in Firefox, it happens to be under the View menu, under Page Source. And as I did a little bit ago, this just shows you the contents of this web page. Now, very often will these contents look like a complete mess. In fact, Google's is particularly messy and particularly compressed, even though I can scroll to the right. Notice they did not waste time being all anal and pretty by indenting their code and hitting enter a whole lot. And that's because when you get 1 billion hits per day and you hit the enter key once and add one additional /n to your file, that's 1 billion more bytes that you have to let your users download over the course of the day. Hit enter twice, that's 2 billion bytes. So one Google employee who hits the enter key can cost Google gigabytes of data just by having white space that we have so heavily preached in this class. Now, this does not mean that if you go work for Google, you start to write code that looks like this. So they actually wrote it, odds are, in a very human-friendly way, but they ran a little tool that removed all superfluous white space, that transformed all of their variable names to just X and Y and Z. These are things called compressors. And even I do this for the course's website and other tools for a couple of reasons. One, you can save bytes, and the fewer bytes you have to send to the user, the faster it goes. That might not matter so much when you're on Harvard's campus, but if you were using iPhone iPhones or BlackBerries or cell phones these days, 3G is kind of a joke. It's not all that fast. So the more bytes you send to a phone for a web page, the longer it's going to take for the user to see it. So just optimizing these kind of details are very important. Unfortunately, it makes it a little hard for us to see how this web page works, but there is a familiar element. If I zoom in, what does Google Indeed have that we had too? Open brackets, HTML, right? So it seems like we know how to implement Google. So they have this. They have a head. There's some other meta tags. And there's definitely some details that we're not going to cover today or maybe ever in the course because they're just not that interesting and not necessary. Some of them like this meta tag. But oh, there's the title. So this is, right, this little piece of text is what gave Google its brand name, right? Open bracket title, close bracket Google, close tag there. So let's actually tease apart some of the interesting stuff. Let me use Control F and search for body. OK, so the real contents of the web page don't start till down here. So let me avoid some distractions. Let me just go ahead. Oops. Let me go ahead and put this into, let's say, Notepad. All right, so it's even messier here. So let me go ahead and do a Control F for body. There's body. Now I'm going to move my cursor over here, and I'm just going to delete all this stuff, because clearly it's not necessary if the body of the web page doesn't start till here. OK, so this is why Google's homepage is white. This is why text on Google's page is black. 00 is all black. This is why links on Google's pages are kind of what color? Blue. So right, the fact that Google's homepage looks like this with blue links is because the links are 0000CC. So that's red, green, blue. So it's not FF, which is a lot. It's CC, which is a good amount of blue. And that's why the links are blue. Now realize Google, largely for compatibility reasons and for financial cost reasons, did not waste time with things like this, though that is expected for the course and just as a matter of good practice. Google is, if your website gets billions of hits per day, you too can start leaving off your quotes. All right. So we've got a body, but then I'm already getting a little distracted here. Let's see. It turns out, let me look for the thing that I know implements the magic. Open bracket form. Any form on a web page, text fields, select menus, and all of this starts with open bracket form. So this, too, is kind of a distraction. So let me get rid of everything before that, because really I want to get to the guts of this web page, which is the form. All right, so it turns out that in an HTML, in a web page's form, there's a few attributes we care about. One is called action, and one is maybe called name. Then there's this table here, but again, I'm getting a little overwhelmed. So let me search for the things that we promised a moment ago are what make all of this possible. So just to recap, this is what the various input mechanisms look like. Open bracket input, so that's all I'm going to search for. I'm going to whittle Google down to its basic building blocks. So open bracket input, there's an input. Whoops, lost it already. Open bracket input. So I really don't care about this to the left. And it turns out Google is actually laying its page out using an element called what, apparently? So they're using a table. So behind google.com, this web page, the fact that some of this is centered and things are kind of in this invisible grid is because Google is using an invisible table that we'll actually use too, because it's very simple, even though some people frown upon it these days. But that's why there's this markup. Everything's being laid out in tabular form. But that's fine. Let's just get rid of that. Here's an input. I care about that. Here's another input. I care about that. Here's a span. I don't care about that. Span, span, span. I don't really care about that. Let me search for the next input just to finish whittling this down. No more inputs there because this one is, yep, over here. So let me search for open bracket, open bracket. There it is. So there's my BR. And here is my Google search. Oh, we're almost done. We almost have Google's essence. And here's another input. And now we're all the way at the other end here. Let's do this, search for this, this. OK, there it is. OK, so we have now whittled Google down to its most basic elements. Let me go ahead and shrink the font so we can actually see that had you thought of this first, it'd be your website and not Google's. That's really all it took to implement the front end, at least, to Google's website. Now, there's still some distractions here, so let's only focus on the ones that really matter. But here is open bracket form. Here's open bracket input. And with these 6 or so elements, can we implement our own version of Google? Let me go over here. I'm going to go ahead and copy hello.html. I'm going to call it fakegoogle.html. I'm going to now open fakegoogle.html. I'm going to rename it here to be proper, fakegoogle.html, re-implement Google. All right, so here's my basic web page. I'm going to get rid of the hideous mess that this thing was. So we're only going to do the important building blocks. So delete, 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 delete. No more red. OK, so now I have a very simple page. We're going to call it fake Google. OK, it'll be anal. Get rid of my trailing white space. Save those bytes. And now I'm going to go back over to my browser here. I'm going to reload fake Google. Oops, what did I forget to do? So there's this chmod command, which we'll explain in more detail on Wednesday. But fake Google, I'm going to chmod it. Then I'm going to go ahead and reload my web browser. OK, there we go. Now it's time to implement Google. So I need to do something here. Let's center it first. Close center. All right, now I need something in the middle. So it turns out there's this heading tag called h1, which means make this big and bold. So let's go ahead and call this fake Google, h1. Now I need a form below it. So let's do open bracket form. I don't really know yet what comes next, but I know what comes at the very end. So form. So forms have to be submitted somewhere. When you click submit, where does the request go to what URL? Well, apparently it goes to what? Search. So let's see. Let's just copy what Google did. So /search. And then that's enough. We're going to skip its name. So now what do I need? I need an input type. What type of input do I want first? A little sanity check. I just think I want to implement Google. What do I need first? Text, right? Just need this big text box. That's all. And then 2 buttons, and then we're done. So input type equals text. I need to give this thing a name so that Google knows what to expect. What was the name given to Google's version of this? Do we see it here? It's in this line here. What is Google's called? Yeah, actually, so let's actually take a step back. Let us search for CS50. So I'm going to go ahead and hit Google search. And now notice what happens in the URL up top. Enter. Notice there's a whole bunch of stuff that's gone on up here. But if we really whittle it down, where is the interesting dynamic part? It's just that. So apparently the mere passing of q equals something into the URL of Google is enough to teach Google to actually search for that phrase. A little aside, I have never once understood why this hit here, CS50, is the laws of Word, and that leads to our web page. So extra credit if any of you can figure out who that guy is and why he has a video on our web page, because it's been there for 2 years. All right. So back to the page. So name equals q. That's going to be the input. So forms work as follows. You define the elements, like whether it's a menu or a text field. You give it a name, because then when you hit enter, those same names end up in the URLs, just as we saw with my browser a moment ago. So let's go ahead and do this. We've got input type equals q. Now let me do input. Turns out there's another type equals submit. And what does Google's button look like? Let's see. This Google's button says what on it? Google search? All right, so let's call this fake Google search. Close quote. All right, and then, all right, fine, we'll do the I'm feeling lucky. I'm feeling lucky. All right, and now let's go back to my version of this and reload. OK, almost there. What do I need to fix first aesthetically? Oh, so I need a line break, right? So I put this line break here with the BR instruction. Now reload. OK, so now we can quibble about other things. It turns out there are other things like size. I can say size is 96, so we can really allow long search strings. That makes it bigger. You know, we can play all day long with these aesthetics. But now let's at least see if the basic building blocks work. So now let me go ahead and type in CS50 and click fake Google search. And unfortunately, bad stuff happened. Because where did I go? What URL? So I did go to search. /search is the root of the current server's hard drive, so to speak, /search. And then notice what happened. So the web form was smart enough to submit to the right action. I told it, go to /search. Unfortunately, I never implemented /search on this server. But notice the more interesting part, question mark, something equals something. This is the means by which elements are encoded in URLs when you submit a form. The browser automatically puts a question mark after the URL, and it does attribute equals value, ampersand, attribute equals value, ampersand. We only have one attribute here because I only gave one element a name, q, but so far so good. Question mark, attribute equals value. Well, let's not actually send our users to ourselves because we never actually implemented Google. Why don't we instead send them to www.google.com? All right, so I'm kind of punting on some of the implementation details, but let's reload. Let's search for fake Google. Voila, I have re-implemented Google. And it works, right? There is that guy again. So what are the basic building blocks here? Well, let's actually do this. Let me just go to the Tools menu. And even though we rarely preach certain software in this course, let me strongly urge you, especially if you have no opinions out the gate, use Firefox as your browser for problem sets 7 and 8 in your final project if you do a web-based one, because it comes with so many free tools for debugging. One of them is this thing. I installed from the course's website this thing called live HTTP headers. And when a web browser contacts a web server, what's actually going across the wire is a whole bunch of stuff you, the human, never actually see. But let's just see what's going across the wire. Let me move this window aside. And now this is just an empty window right now. Let me go ahead and click fake Google search. Enter. So a whole bunch of stuff just went across the wire. Well, when you type in http:// what is that? So HTTP is a protocol. It's a language on its own that is a language spoken by web servers and web browsers. How do you get data from point A to point B? You speak this language called HTTP. Now, earlier today, I kind of dumbed things down, and I said, well, the browser asks for CS50.net's homepage. Well, what does that really mean? It's not going to write it in an English sentence, give me your homepage, but rather it's going to encode it with this query. If you've ever heard of a GET, and it's fine if you haven't, it pretty much says what it does, that one blue bold line there is all it takes for a browser to make a specific request of a server. In this case, what has my browser, upon hitting the submit button, asked Google.com, the server in question, to give it? Give it the result of asking for /search, ? Q equals CS50. And then there's all this other stuff. So there's a lot of metadata. For instance, this line here reminds the server what URL was requested. Here's some information on what browser I'm using, fairly cryptically. There's a bunch of other stuff. And then finally down here, we get a response from the server. The server tells us, hey, here's a cookie, which we'll discuss on Wednesday. Hey, here is some caching information for performance reasons. So in short, there's a lot of stuff that's going on behind the scenes. But at the end of the day, my whole request boils down to this simple query here. Well, this is only so interesting when I've implemented just the front end. Well, back in the day, before PHP actually existed, I think that's an accurate statement, the freshman intramural sports program had, as I may have said in the past, a really fancy system for registering for sports. You would fill out a piece of paper. You would walk over to Wigglesworth C or D. You would knock on the door and get let in. And then you would find the proctor who lived there, who ran the freshman intramural sports program. You would then submit your form through the mail slot in that person's door. And then voila, you were registered for Frosh IMs, unless the paper got lost and bad stuff like that. Right, this was in 1996, a really obvious opportunity for automation. And at the time, actually, literally, I had just taken CS50 and then CS51. There was no web programming in the course then. I had no clue how to do this, but it was an excuse at the time to teach myself Perl, which was a language very much in vogue at the time, and still kind of is. But I used it and taught myself to make web pages. And actually, the first one kind of looked like this. Because what does it mean to register for freshman intramural sports? Well, the proctor needed to know their name, their gender, whether or not they wanted to be a captain, perhaps, and then also their dorm. So even this interface way back then boiled down to some very basic constructs. Thankfully, PHP makes this stuff much more interesting. But clearly, when I click this submit button, I can't submit it to Google, because that's completely useless. I'm going to have to submit it to a file on my own server. So what we haven't yet seen is the ability to actually implement logic ourselves. We implemented some HTML and some CSS for some ugly aesthetics, but then we completely punted on the logical design of Google by outsourcing that part to Google. So what we'll do on Wednesday is actually implement the back end of this. And the motivation here, to be clear, is that when you exit this course, you won't know just C. And you'll be struck, I think, over the next couple of weeks, even if some of this moves quickly and you feel like, wow, we're really not learning PHP as much as we did C. That's the whole point, because you're not going to have a course to teach you the next 20 years worth of languages. The point of the next several weeks are to help you realize how you can teach yourself new languages, because there will be many over the course of your lifetime. So with that, PHP on Wednesday.